Okay, I think we're going to go ahead and get started. Like I said, the last session before we go to the reception. My name is Margaret Lewis, and I'm Software Strategy Manager at AMD. And in that position, I get the honor of deciding the types of software solutions that run with our AMD Opteron processor, which is our server workstation processor. My background is once upon a time in a galaxy far, far away, I was a COBOL programmer and moved. I could have made a lot of money a couple of years ago. And I've done database programming and worked in high-performance computing, and so I have a background where I understand a whole lot about what are the requirements for software. And so over at AMD, I spend my time looking at our processor roadmap, and our software solutions roadmaps. And so what I want to do today is introduce you to our AMD64 technology, maybe in a different way than you've had it taught to you about. I'm going to approach it more as a platform for running software. Tell you a little bit about some of the underlying functionality that makes it a great software platform, and then give you some proof points to help you see how it might work into your current infrastructure. In Steve Ballmer's keynote today, he started out by talking about how all of us have to do more with less. And even in a company like AMD, our IT department has the same kind of struggles as any IT department. We're always looking at how to accelerate application performance, improve asset utilization, reduce computing complexity, minimize user disruptions. There's nothing worse at AMD than if our email goes down, and control data center cost. So in trying to answer these challenges, what we've looked at with our processor design is to provide IT with a way of providing users top application efficiency and performance today, while offering tomorrow's 64-bit computing solutions with minimal disruptions in cost. Now you might say, why 64-bit computing solutions? At WinHEC a few weeks ago, Bill Gates in his keynote challenged the hardware developers in the audience to get on board with 64-bit computing, and he stated that by the end of 2005, all of AMD's processors and most of Intel's were going to be 64-bit enabled processors. So let's take a little minute and say, why 64-bit computing? And really, from a software standpoint, there's two things you're going to get. One is efficiency, and the other is performance. So in terms of what 64-bit computing can do, it gives you increased capacity. You can move larger amounts of data, and it can be processed faster. One of the demonstrations that they gave at WinHEC was taking a workstation that was running a copy of the Windows XP 64-bit beta for extended systems, and a graphics-intensive application, Unigraphics, used a lot by manufacturing. They had an engine design that was done by GM. This particular engine was a very complex image, and it took 2.5 hours to load on a 32-bit system, and it took 10 minutes to load on a 64-bit system. And that in itself, to me, was one of the best demonstrations to show you how a 64-bit system can help you when you have to move a lot of data. That wasn't manipulating. That was simply loading the data. Server consolidation. There's a lot of talk about doing more with less. And you can use 64-bit computing with so that you can have larger workloads that can be deployed on a single server. I'll have some examples for you with some of the benchmarks we have to show you how a server can be used to cover more uses than what is happening today. And also performance. Complex calculations can be done in minutes. Now, you might say, I don't do complex computations or calculations, but this is in essence that a lot of the decision support software that our users run today. Now, because I grew up being a programmer, I grew up also understanding this is what the traditional 64-bit computing world looked like. There's 32-bit systems on one side of a brick wall and 64-bit systems on another side of a big brick wall. Now, interestingly, not only are there separate hardware infrastructures, different cooling, power, enclosures. There's also separate software environments, different OSs, different licensing schemes, different deployment, different tools, different management. And then users and administrators have to know how to work both environments. Now, my husband happens to be a system administrator, and he's fluent in both Unix and Windows, and he can do 64-bit and 32-bit, but he is a very unique character. And I used to have a little sheet that was Unix for Dummies so that I could remember how to do the Unix commands I needed to do to survive in another job I had where I had to go into a Unix server on occasion. And so this is how the world is today. This is really what AMD's vision is to change the whole approach to 64-bit computing. And so what we did is we took the x86 instruction set and added 2 new instructions to it. By extending this instruction set, we made it capable of doing 64-bit addressing. This allowed 32-bit x86 applications to continue to run. And our goal with the design of our processor was to let them continue to run without decrease in performance. If you go back to the Unix world, they did a 32-bit to 64-bit conversion, but a lot of times a 32-bit application running on a 64-bit OS suffered a performance degradation running in that environment. We also wanted 64-bit applications to be developed using familiar techniques and tools. One of our most valuable assets today is our software base. There's thousands and thousands of software applications that have been written, tested, deployed. We don't need to scrap every piece of software and start over. And so we wanted to make sure as we implemented this method that we allowed developers to use the tools that were already familiar with them when an application needed to be ported to 64-bit. And then we wanted users to have a flexible migration path to 64-bit computing. We didn't want that brick wall to continue. And so our approach has been our AMD64 technology. And I'm going to talk specifically about the AMD Opteron processor. And there's 3 things that we can talk about that tell you why the architecture works. And one is a 64-bit processor core. Another is our integrated memory controller. And another is a chip-to-chip interconnect technology called hypertransport. Now, we truly believe that just extending x86 and making it 64-bit is not the answer. This is an interesting timeline. It shows you the x86, x86 instruction set. Yeah, that's, I think, fair to call it that even when it was 8-bit, but it's evolution. And so you can see the move from 8-bit to 16-bit did not take that long to happen, or from 16-bit to 32-bit. You can see 32-bit kept us happy for a long time, but now we're to the point of needing to change to 64-bit. However, just extending the instruction set and moving to 64-bit without easing potential bottlenecks of the front-side bus architecture that's used today by x86 processors adds little value. And so all of our research said it isn't just about 64-bit, it's about changing the underlying infrastructure so you're capable of moving data more effectively. So let's take a little look at system architecture. Today, this is a common front-side bus architecture. The CPUs access memory and I/O hubs via the front-side bus. Right here you can see in this 2-processor example that this immediately gives you a bottleneck. The processors have to go through the front-side bus to get to the memory controller and access the memory, as they also have to go through the I/O hub to access any I/O activities. Our system approach is different. We integrated the memory controller directly into the CPU. And we interconnected the chips together with a hypertransport technology so that I/O is directly connected to the CPU, memory is directly connected to the CPU, and the CPUs are directly connected to each other. We're going to look at this more in detail, but what you immediately see is our paths of flow are now not through just one common bottleneck. The other advantage is as our processor increases in megahertz, gigahertz clock speed, the memory controller is integrated and it increases in clock speed. So there's no need for us to have to make a major switch and bring the front side bus to a new speed, causing all the chipsets and infrastructure to move with it. So let's look a little closer at some of the different aspects. First is the integrated memory controller. So what this provides you is lower latency memory access, which provides you faster data access. So that example I was giving you of this image loading instead of in 2 hours and 15 minutes, in 10 minutes is a direct result of being able to have fast memory, and in that particular case, combined with 64-bit addressing capabilities. So memory bandwidth scales with each CPU that's added. This particular drawing shows you one CPU and its pool of memory. In a little bit, I'll have a drawing that will show you what a 4P system looks like. But every time we add a processor, it has its own integrated memory bus and its own pool of memory. So it scales. It isn't just throwing in another processor and more memory on the same bus. Memory does not share the bandwidth with I/O. This is a major point. Memory access and the I/O access are separate paths. And this means that we don't have a bottleneck as we do our I/O activities. And then finally, as I mentioned before, the CPU frequency increases, memory controller becomes much more efficient. So if you notice benchmarks, you will notice that we continue to scale as we add higher performing models into our family. And some of the scaling you see, you might think is quite out of proportion. You know, we've had people say, no, wait a minute, I'm seeing linear scalability. How can I see this? I'm seeing performance gains that I don't think are possible just by this type of increase. Well, we're not just increasing the speed of the processor, but the whole memory bus that is connected to the processor also gets increased. Now, the memory controller being integrated is a first big step, but you still need to make sure that the different chips in your system are connected together effectively. And so we've chosen hypertransport technology, which is a high-performance chip-to-chip interface. This particular technology was invented by AMD with contributions from the industry partners. We wanted it to be an open standard. We did not want to own this technology. We felt there were too many people who could be beneficial contributors to it and also could benefit from its use. So hypertransport is managed and licensed by the Hypertransport Technology Consortium. So what does hypertransport do for us? The first thing we're going to look at is what hypertransport technology does in terms of I/O. So first, it provides a scalable bandwidth interconnection between processors, I/O subsystems, and other chipsets. So in this particular example, the yellow arrows show you the different paths that these chips are taking with hypertransport connections. Each processor has a peak 19.2 gigs of bandwidth, and then there's 6.4 gigabits per second bandwidth per link for I/O activities. So what happens is we reduce I/O bottlenecks when they're not coming with the memory controller. This is also a very flexible standard that can connect new interconnects, including PCIX, DDR, InfiniBand, 10 gig, Ethernet, PCI Express, whatever types of interconnect standards are emerging. And also, it reduces the number of proprietary buses. This becomes extremely important when you start moving into a multi-processor system. And I'll show you that, I think, on this next slide. Yeah. Now, we talked about it in terms of I/O, but let's talk about it in terms of interconnecting processors. So we think of hypertransport as allowing us to have what we call glueless multiprocessing. In a sense, what it does is it creates a Lego-like system that allows us to interconnect the different chips that are in the system in as many different ways as a designer can come up with. There's a cache coherent mode that enables the processors to be able to share data without any coherency issues. With the integrated memory controller, the hypertransport enables scalable multiprocessing. So let's take a minute here and look at the system design. You see the 4 processors, and you see that each have their own pool of memory. This is a memory structure that we call NUMA, non-uniform memory access. In NUMA, the fastest memory access is the local pool of memory to a processor. So as you can see here, any one of these 4 processors has very fast memory access to the pool that's directly connected in the integrated memory controller. However, the processors also can access the memory attached to another processor. And this immediately brings up a latency or a delay. Using hypertransport, we keep that delay to a minimum. In fact, the longest delay we have in this 4P system gives us a latency that is still a lot lower than the latency of a front-side bus system. So we have very fast local memory and very fast non-local memory, the memory to another processor. Yes, sir? Our processors can do 8 in this glueless fashion. And then we can use what you would maybe consider a crossbar type system built on hypertransport to start connecting these 8P modules together. Out of the box it does 8 though. Today we have systems selling that do 4 and anticipate that we'll have system designs out in the next year that will do 8. The hypertransport has a really distinct advantage of lower power consumption, which reduces the system's thermal budget. In a 4P processor, the chipset, the North Bridge, is itself a very powerful chip processor, and it takes a lot of heat. The way we've done the chips, putting them together, the different support chips we have are really bridge chips, and you see the word bridge on them, or hubs. We don't necessarily have them be complete intelligent chipsets as you're used to in your front-side bus system. And so we use a lot less power this way. So what you can start seeing is this particular design has an advantage of lower power, it has an advantage of lower latency, and it has an advantage of high-speed I/O. The last point really here is that it changes the economics of 4P computing. When have you ever asked yourself why is a 4P server so much more expensive than 2Ps? I mean, when you start thinking about it, it's the same amount of pieces, and you think that there would be some economy of scale because you could pack them into one system. Well, one of the answers is the supporting chipsets that go with a front-side bus 4P system are very expensive chipsets, expensive to develop, expensive to market, and they add a tremendous amount of expense to the system. So if you come by our booth, or to HP's booth, you'll see that we have a 4P system by HP, DL585. That system is a very economical system that is starting to really post some tremendous benchmarks. And so with this particular design, we really want to redo the economy of a 4P system, make it an affordable system, make it an alternative. And this is the kind of server that you could then use for that server consolidation, because now you have a very robust server, can have dual power supplies, all the reliability features you want, a lot of memory that can be used to support many different applications. So this leads to the point of what our technology can do for you. AMD Opteron can really be a unifying force in the data center. This particular quote comes from a Giga Information Group study that was done in 2003. And they said that the AMD Opteron processors can provide a single platform for complex needs of the data center, reducing costs as much as 25%. And so here you see some examples of where you could deploy an Opteron solution in a data center. You could be using it in a 64-bit compute farm, 32-bit messaging server, 32-bit web server, 64-bit terminal server, 64-bit database servers, 32-bit file and print servers. Notice that it is one architecture that supports these various types of 32-bit and 64-bit computing. It's the kind of server you buy that will dictate what the use of that server is, the kind of applications you run on it. And so this could be a tremendous boon in terms of having your staff not being trained on one platform, management and users. Also, having like systems makes it much easier for management. Having systems that have the same power infrastructure, the same rack infrastructure, all of this can be a big advantage. So to look at this and say, now this is really a fantasy and not a reality, what I want to do is take you through some different scenarios where we can look at what some of these different servers might look like and look at some of the benchmarks to give you an idea of what performance is today. And these benchmarks are just not numbers to show you who ran the fastest. And with each benchmark, I'm going to show you some aspect that that benchmark shows you about this architectural design that we've talked about. So let's look at what's the most common server. Someone once said this was the M&Ms of server, file and print. So in the file and print servers, file servers need to store, retrieve, and share documents and programs within an organization, and print servers need to manage the printing functions in a network environment. And these are critical servers, maybe not business critical like your database servers, but they are critical for user productivity. And one of these servers going down ends up eliciting a lot of calls to the IT department to try to figure out why the print server isn't working. And of course, somebody has already rebooted it and taken it off the network 2 or 3 times and has interceded in a way that you probably wish they hadn't. If it's like our shop, we try extensive troubleshooting and then IT screams at us for having done that. So what can an AMD Opteron server do for file and print? AMD64, but well, to begin with, file and print servers need I/O more than megahertz. These are not necessarily a server that has to be the top of the line processor in terms of speed, but it needs to have fast I/O. So our 64-bit, AMD 64-bit technology reduces the memory latencies with cached data. And the lower frequency, you can use a lower frequency processor that outperforms competitive processors that are almost twice the frequency. For our Opteron, we have an 89-watt processor, which is always our top performer, a 55-watt, and a 30-watt. Now, all of these, if a processor is a model number, it always performs the same, no matter what wattage it is. So if I have a 146, a one-processor model, whether it's a 89, a 55, or a 30-watt, it always gives you the same performance. But when we offer a lower power processor, we might not offer it at the highest available performance model. So right now we've just introduced a 150 part. You can't get that 150 part in a 55 or a 30-watt part yet, but it'll be coming. So you can kind of see the scheme. We guarantee you the performance. We don't take the performance away because of lowering the power. So what does this translate to? AMD Opteron processors running Windows Server 2003, the 32-bit version that's available today, can support more users at increased levels of throughput on a server that has lower power consumption. And that server can scale as a business grows, sustaining performance even as the user load increases. Now, to show you this, here is some NetBench performance benchmarks. These were all done with 32-bit Windows Server 2003. These were all 1P servers. These were all also not top-of-the-line processors in terms of performance characteristics. So we're not looking at having the highest performing CPU, but we're looking at getting good, solid performance and scalability. Here, the Opteron server is about 3% performance increase at about 1/2 of the frequency of the similar Pentium processor. And what's interesting here is we show you a 144 Opteron and a 142 Opteron. So we show you the 142 is a less powerful processor than the 144. And the 142 still maintains a performance lead. And then we've given you a chart to show the scalability increases. So as the number of clients increases, you see that performance maintains. And so what this allows you to do is to be able to use a file and print server that is more effective. Now, because the Windows 64-bit OS is not yet available in a production release, we cannot produce benchmarks on it. But if you were in Bob Kelly's presentation just prior to this, he noted that a file server running a 64-bit copies of Windows is that they see it 111% increase with Windows 64-bit. And so some of the benchmarks that we've done is showed that as you move your servers from a 32-bit Windows Server 2000 to 64-bit Windows Server 64-bit Windows Server 2003, that you can get yet another increase in performance by just an upgrade to the OS. And a tremendous increase in performance at that point, because here is an application we're handling large amounts of data, or being able to cache large amounts of data are definitely, in memory, is definitely beneficial. So let's move from file and print to servers that are a little more exciting. So let's go for web infrastructure. So web servers, what we're going to do is deliver static and dynamic web content to users, and they're going to access it via their web browser. And this is considered a business-critical server for e-business applications. And obviously, there was a lot of talk today in many of the sessions about having network-enabled applications using XML, using Visual Studio, .NET Framework. So web servers demand superior I/O performance in memory response time. So once again, we're looking at servers that really maybe are not looking for the top-of-the-line CPU, but need good I/O and good memory response time. So obviously, the memory, integrated memory controller and hypertransport for help boost our memory and I/O performance. And this increases the number of user connections while reducing response times. This translates into a 1P AMD Opteron processor-based server running Windows Server 2003, the 32-bit version today, it being capable of supporting more users at increased levels of throughput than a comparable 2P x86 server. And servers can also offer better scalability and sustained performance as the user load increases. So this is a WebBench 5.0 performance benchmark that HP has published and is on HP's site. This is featuring their DL145 2P1U Opteron-based server. Now, interestingly enough, if you look at the 1P number, which is the green with the square, you can see that a 1P Opteron beats a 2P Xeon in performance. But I think the more interesting thing to look at is the 1P Opteron and the 2P Opteron. And so I've called that with the AMD64 scalability note for you. And so this is how scalability looks when you have an integrated memory controller and hypertransport architecture, as opposed to the blue lines, which show you what scalability looks for a 1P Xeon to a 2P Xeon system. So here's where getting rid of the front side bus, going to this better architecture, this is before you even put 64-bit Windows on the system. And so the 1P Opteron server beats the 2P Xeon by 32%, and the 2P Opteron beats the 2P Xeon by 57%. And that's also with a lower powered system. Once again, if we go back to the talk that Bob Kelly just gave, which was like standing room only, he references the fact that moving web serving to 64-bit OS gains you yet another increase. And I believe the increase he was quoting there was another 11% moving to a 64-bit OS. Okay, let's look at the one server. If we ask people what's the one piece of software that needs to be 64-bit on the system, they almost inevitably say two answers. One is database, and if they're a real game enthusiast, they might say my games. So let's look at a server that nobody will argue with needs to be 64-bit, and that's our back-end database server. So here, it's going to maintain data records, ensure end-user access, protect data, and communicate with other servers and clients. And this is business critical for resource planning and business processing. So database servers, once again, are memory and I/O intensive. Now, having CPU power is important, but a lot of times you add more CPUs to your database server as a way of getting more memory and more I/O as opposed to a way of getting more CPU. And we'll see this in a minute. So with AMD64 technology, the lower memory latency, balanced and dedicated I/O with hypertransport eliminates the bottlenecks that are found in the traditional x86 systems. And so this translates into very good TPCC and SAP SD benchmarks on 4P servers that are running with Windows Server 2003 and Microsoft SQL Server 2000 today, 32-bit statements. And this also provides a straightforward path to 64-bit computing with the same hardware infrastructure. So this is TPCC performance scores. Once again, these are found on HP's site. They did this with their DL585. And the thing to note here is the Opteron server gives you more performance, more transactions per second. It's also a lower power consumption. And how do I know that? HP has a very interesting little power consumption chart that when you configure your server, they'll help you decide how much power that server will use. Once again, it's on their home page, and it's a very interesting exercise to go configure a server and see what the total power consumption will be. This is the SAP SD, which stands for Sales and Distribution, Standard Application Benchmarks. This was published, once again, HP published this on the 4P server. I want to point out an interesting fact here is that the Opteron processor here running 32-bit software outperformed two Itanium servers running 64-bit versions of the same software. So it isn't necessarily 64-bit that gives you performance. You can have 64-bit and not gain performance if you don't have the right architecture. Once again, this is all done with Server 2003, either a 64-bit version for Itanium or a 32-bit version, the x86 version. So there are other transactional servers which we've put kind of together just for the sake of time. One is a messaging server for doing email, and then terminal server for delivering mission-critical applications to other computers. Once again, in Bob Kelly's talk that just happened, he referenced moving to the 64-bit version of Windows for extended system with the 64-bit terminal server that's built right in. Once again, another great increase. I think he quoted a 50% increase in moving to 64-bit for terminal services. This will allow you to handle more user sessions and more users effectively and efficiently. In terms of Exchange, there is an MMB3 benchmark that's been published once again showing an Opteron 4P processor beating a Xeon 4P processor. Here, what I want to call out to you is the fact that in all of these charts, the Opteron processor has smaller cache. Now, cache is just like clock speed. These are all techniques we use to get performance with the processor. And so if we can get the same performance with smaller cache, we're going to use a smaller cache because a smaller cache means a processor that's going to use less power, that's going to be more efficient, that's going to cost less. And so the cache has been in the last couple of benchmarks, but I wanted to point out here, a lot of people think a larger cache is good. A larger cache is good if it gives you more performance, but you need to say, are you doing a larger cache to get the performance at what expense? Is there another way to architect the system so that you can get the same performance without having to take the penalty of a larger cache? Okay, and I don't know if any of you are interested in workstations, but since the Opteron runs on workstations, I thought I'd put in a slide just to let you know that workstations used by developers, designers, engineers, scientists, and software developers to create software programs, digital content products, and to visualize data. Workstations need fast memory access, high-performance I/O, and mathematical processing. Workstations is probably the one platform that needs everything to work well for it. And so we deliver integrated memory controller and abundant floating point resources. We have lots of benchmarks published on our homepage, and our partners are publishing a lot of benchmarks that shows how XP 32-bit today can do a great job of handling complex files, reducing user wait time. IBM just introduced a 2P Opteron-based workstation that's catching a lot of attention, and they have some very compelling benchmarks with that. So I invite you to go take a look at our homepage if you want to look more at that particular data. So really, when it comes to AMD64 technology, we feel like we're answering the challenges that we're seeing by the IT community today. We're delivering top-end performance for today's 32-bit applications, providing an architecture to deliver the benefits of 64-bit Windows. And then we're taking a customer-centric approach that helps you to preserve the investment that you've made in hardware, software, and staff. We have a lot of public information on our homepage that will help you learn more about the architecture, the AMD processor information. We have an ecosystem presentation that helps you see what software is moving to 64-bit. Remember, your software doesn't have to be 64-bit to take advantage of the extended system architecture, but there is this ecosystem presentation. It's updated monthly, and it helps you see which vendors are starting to move to 64-bit and what 64-bit applications are currently available. If any of you have downloaded the XP or Windows Server 2003 64-bit beta, we have a device driver information page that will help you get your hands on device drivers that are 64-bit. These device drivers, a lot of these companies have put them out as beta. You can pull them down. They weren't necessarily included with the beta OS, but this page will help you find device drivers. And then if you're looking for developer resources, that we have a lot of information about developing software for Opteron. And so I've left time because it's usually in a discussion like this, there's a lot of questions. And so be glad to take questions, and the only request I have is you need to go to the microphone to say your question so that they can record this. So, any questions?
I missed the last session. When do you expect that Microsoft will be releasing Windows Server 2003?
Their public statement is that it'll be released in the fourth quarter of 2004.
Looking at the desktop side, you have the AMD64 and the AMD64 FX 51, 52, 53. Could you go over just briefly what the difference is between those two processor types?
You know, I am not the best person to do that because I'm really from our server workstation group, but if you have time to come by our booth, I could get someone to address that for you. Unless someone from AMD is here who can do that. Why don't you come over to this other microphone? Sorry, we have someone who could help address that. And if anybody doesn't want to stay for the Q&A, please feel free to leave, and thank you for attending.
Yes, our FX processors have dual 128-bit memory, much like the Opteron, while our Athlon 64 processors have a single memory controller. So the FX line may also have an increase of cache size, and it's mainly intended for the high-end desktop or even the workstation for a 1P type of applications.
Okay, thanks.
And the L2 cache, yes, that's what I meant to. Right.
His mic's not on? Oh, sorry. We made an attempt. Other questions? Yes.
I was curious how closely AMD is working or looking at the PCI Express technology and using that to get the most advantage out of 64.
Yes, we have a statement of direction to make sure that we are compatible with PCI Express. Now, that will be done through a lot of the partners that we have who do chipsets or some of the supporting hub chips. And so people like NVIDIA via ServerWorks, some of the usual people for producing those kinds of chipset infrastructure would be the people that you really need to talk with to see what their stated roadmap is for PCI Express. But there's no reason why we can't support it from a processor standpoint.
I'm not going to bother with Mike because it turns out that I noticed on the diagrams that each processor has a direct connection to the memory bus, its own connection. Does that mean that from a hardware perspective that you need to actually add memory buses as you add processors? Does that make that much more expensive?
Each processor has a memory bus, and the best performance is for each processor to have memory hung on that processor. And I don't see that is as, in the front side bus, if you were going to, each processor had the capability of 4 DIMMs. They were just on the other side of the front side bus. It's no different with our technology. Did you guys want to add? I'm kind of the software guy, so I'm going to look at some of our hardware guys to see if there's.
I guess a short statement then on top of Margaret's answer, that it doesn't take up a lot of real estate. I think so therefore, there's no cost.
Yes. Well, let me address the Oracle question. Oracle has released Oracle 9i Linux for AMD64, and Oracle doesn't certify boxes. They certify OSs. And so they've certified that under Linux and Windows. And Oracle has released a developer release, and we're showing it in our booth, of Oracle 10G for Windows that you can go download today to start using it with a 64-bit OS. And once again, Oracle does not certify boxes. They certify operating systems. Now, if you have an Oracle site that's a non-US site that you access that shows you systems being certified, if you let us know, we will work back with Oracle to help address that question. But Oracle's statement is they certify OSs, not boxes. And so now the boxes get certified by the OS vendors. So all of the systems that you've been seeing that we show the benchmarks on are all WCLed by Microsoft or certified by whatever OS vendor. So if the OS vendor hasn't certified the box, then you're going to break the chain with Oracle. But Oracle 9i is shipping 64-bit for Linux. Oracle 10G, a developer release, is out for Windows. And if you want to, you can talk to me afterwards and we can talk about the Oracle certification and see if we can help you. Can you guys, I didn't catch maybe all of his first question. Did you catch his first question? And could you, yeah.
Okay. If I understood your question, you were saying that some of the boxes that you're seeing don't utilize the full memory capacity that our processors can actually. I think that's more of a system builder question. Some of our reference designs that we have in-house, for instance, for an Opteron processor, it can handle 2 channels of memory with each channel containing 4 DIMMs, DDR sticks. So that's 8 sticks per processor. Now we know that 1 gigabyte sticks are on the market, and pretty soon there'll be 4, and it won't stop there. So in theory, each processor could handle 8, so that would be 16 sticks. Some of our reference. At least this one.
Well, we know one of them works now.
Yeah, that's right. Test. Yeah, maybe this one's working a little bit. Okay, looks like it finally came on. Okay.
Did that wake everybody up now?
That's my singing voice, everybody. So probably it's more of a real estate issue and a system vendor issue at this time, but I'm sure we'll probably see boxes that actually do utilize 16 sticks of DDR memory for a 4P system. Does that answer your question? Okay.
Right. The Intel AMD64T processor, as far as instruction set looks like, it looks identical to ours. There's numbers of reference papers that are out on the web where people have actually compared line by line and can tell you at what point in time from our documentation that they felt like the AMD64T was created and developed. Microsoft has stated, and once again Bob Kelly stated again in his presentation, it was going to be one binary that from both these processors had to be binary compatible to run Windows. As Intel is like AMD, we are free to add whatever we want to the instruction sets, and so down the line you don't know who's going to add what to an instruction set, but as of right now, the front side bus is obviously the biggest differentiator between AMD and Intel right now. I don't think that of anything else that we have published and know of. There are not AMD64T systems out available for resale right now, so I think we need to take a look at how they look when they come out, and we can evaluate that. But as far as I know, instruction set, they're going to be identical enough to be able to run the same binaries, and front side bus is a major architectural difference between Intel and AMD. You guys, anything? That's it? Yeah, okay. Okay. My hardware guys are saying that I did good on that one. TCP IP related benchmarks. With AMD, when we publish benchmarks on our homepage, we publish industry standard benchmarks that are certified by whatever the standards body is. And so there isn't a benchmark specifically, I know, that's measuring what you're looking for that we publish. We publish it so it can be certified, so our legal department is happy that it's there. Now, it might be an interesting question for you to go back and ask to some of the system builders who are building systems for us, who themselves carry different kinds of benchmarks to show their system, because I think that you might find one of them has published a different kind of benchmark than we're publishing. Do either of you guys see anything? I mean, most of ours are just the same standard benchmarks that you see, the spec, web bench, net bench, TPCC, yeah. Oh, okay, now, right. Now, in that particular case, on our homepage, we have a lot of high-performance computing benchmarks. And so if you go back to our homepage, or if you talk to me afterwards, we can talk about a lot of the high-performance computing benchmarks. And if you take your data from there, I think that I can give you lots of proof points.
Do you have more?
Go
ahead. Okay.
Do you have more benchmarks against titanium?
To begin with, we're positioning ourselves against Xeon, not Itanium. The second thing is it's really much better if you have an apples-to-apples comparison. And so I showed you a benchmark that was 32-bit to their 64-bit, but a fair benchmark is really if they're both running 64-bit or both running 32-bit. So we are moving benchmarks along to be 64-bit for both our desktop and server workstation world, so we'll have fairer choices. And in some cases, like in web serving, the 64-bit software isn't available for Itanium to run the same benchmark. So there a lot of times you can't run the same benchmark, and so there is no comparison. In general, if there's a comparison that can be made, you'll find that people are making it. If not, that usually tells you that the benchmark isn't there or the software isn't there. But if you look, if you go and do AMD Opteron benchmarks like on Google, you can find all the third-party people in the world that have done benchmarks, and a lot of them do what we consider apples and oranges comparison, but it will help you to kind of get a feel. Yes, sir.
This should be a pretty quick question. While we're waiting for Windows 2003 for extended systems, do you support PAE, 36-bit addressing, right now? So, for example, if we buy one of those nice DL585s and put 16 gigs of RAM in it?
Yeah, it isn't so much a question of the processor supporting it. Does the OS support it, and does the application support it? And
well, there's two things. I mean, when you're dealing with applications, even if the application doesn't use the window addressing extensions, the working sets can still be in memory side by side, thanks to PAE support, because it adds a second layer of abstraction from memory by the memory manager. But with that said, 32-bit Windows, Windows Server 2003 Enterprise Edition supports PAE along with Data Center Edition. Do you guys support that?
Right. Those run on us, and we're certified to run. We don't have a data center version 32-bit, but all the other versions are certified through the fact that we're wickled and can run on us.
Okay, so I can put that /PAE switch in?
That's exactly right.
Okay, cool. That was me.
Right.
Thank you.
Just an informational question. We know that IBM is building supercomputers with their power chips. Is any company building supercomputers with their
Yes, if you look at the top 500 supercomputing list in the world, AMD has about, let me see if I can remember the exact number, about 12 to 13 clusters. And last year when that list was published in November, 5 of those clusters were Opteron. The rest were our Athlon XP or MP parts. That list will be republished in June when they do the supercomputing show in Heidelberg, Germany. We expect to see numerous Opteron clusters on that list. So one of the earliest adopter markets for us has been the high-performance computing community. They're doing a lot of work at clustering. They've been very happy with the performance and price performance they're getting, and we have many, many wins in that area. And once again, if you go to our homepage, you can see a lot of success stories that show that community. And it's interesting that at this kind of IT convention that you would bring that up, because we see that you guys are keeping track of that too, huh? Any other questions? I need to invite you to come back and see our booth. We have some great demonstrations. You need to go to the hands-on lab. And for fun, go to the gaming pit so that you can really experience what 64-bit computing is with some of the Athlon 64, Windows 64-bit, and games. Thank you.